Today the topic we are going to discuss with you is properties of colloids. Before enter this topic, it is necessary to understand what are the types of colloids, what is colloid, what is the difference between colloids, true solution and suspended particles. Colloid is nothing but that is a kind of solution. We know solution means two components will be there, one is solvent, another one is solute. The major component present in the solution is said to be solvent and the minor component is said to be solute. The function of solvent which dissolves the solute and the solute is dissolved in the solvent. Like so, colloid also contains two phases. One is dispersed phase, another one is dispersion medium. Dispersed phase is nothing but it will have some minute tiny particle size and the particle size is between 1 nanometer to 100 nanometer. If the particle size is less than 1 nanometer, then it is said to be true solution. If it is greater than 100 nanometer, we can say that is a suspension. Then dispersion medium. Dispersion medium is said to be continuous medium, that is solvent. Generally we can say that is a water. So colloidal difference between colloidal particles, true solution and suspended particles. Colloidal particles is as I said earlier, that is 1 nanometer to 100 nanometer. Anything is less than 1 nanometer means we can say as true solution. Then another one is greater than 100 nanometer, that is we can say as suspended particles. Then true solution. True solution means the particle size is very less. It cannot be visible even by using powerful ultra microscope. But in the case of colloidal solution, we can see the particle by using ultra microscope. Then true solution, when you are passing light, which will not scatter the light, but when you are passing the light through the colloidal solution, we can notice the path of beam. But in the case of suspension, it is opaque. Light will not enter through the suspended particles. So another classification. Based on upon the classification of physical state, colloidal system can be classified into 8 types. First one is dispersion. If the dispersion phase is solid, dispersion medium is also solid, we can say the common name of the colloidal system is solid sol. For example, this kind of solid sol, colored gem, alloys and colored glasses we can say. Second one is if the dispersed phase is solid, dispersion medium is liquid, then the colloidal system is sol. We can say paints, starch, then ink. These are all the examples for this the colloidal sols. Then if the dispersed phase is solid and dispersion medium is gas, the common colloidal system name is aerosol. We can say smoke and dust as examples. Then liquid and solid. If the liquid is dispersed phase and the dispersion medium is solid, we can say gel. Example, gel is keys, etc. Then if the liquid is dispersed in the dispersion medium of liquid, that is said to be emulsion. Examples are milk, curd, etc. Then if the liquid is dispersed in the gas, then the colloidal system is said to be liquid alcohol, liquid aerosol, etc. Mist, fog, cloud, etc. Then gas. If the colloidal system is aerosol, we can say gas is dispersed in the solid, that is solid foam. Example, foam, rubber, pubic stone. Gas is dispersed in the liquid, then the colloidal system is said to be foam. Example, froth, whipped cream, etc. Then based upon the interaction between the dispersed phase and dispersion medium, we could say the colloid system has 2 types. First one is leophobic colloids and leophilic colloids. What is leophilic and what is leophobic? First, leophilic. Leo means in Greek name, that is solvent. Then philic means attraction. So there is a force of attraction between the 2 components of dispersed phase and dispersion medium. So that is what leophilic colloids. Example, starch, then gelatin. These are the example for leophilic colloids. Leophilic means also we can say that is attraction or what liking. But in the case of leophobic means, as I said earlier, that is leo means solvent, phobic means hating, that is solvent hating. So, in these systems we could see there is a force of attraction is very weak, especially van der Waals force of attraction will be established between the dispersed phase as well as dispersed medium. Example, we can say ferric hydroxide and aluminum hydroxide. Properties of colloids. Now only we come to enter the properties. So, especially kinetic properties of colloids, then electrical properties of colloids and optical properties of colloids. First we could see kinetic properties of colloids. We know kinetics. What is kinetics? That is movement, the movement of colloids. Actually, dispersion medium, in the dispersion medium, dispersed phase will be moving. The particle size is less, but the viscous medium is high, then the movement of particle will be less. If the particle size is less and dispersion medium viscosity is low, then the particle can move very fastly. Then in a powerful microscope, Robert Brown, he observed the colloidal particles. That time he could notice the colloidal particles were moving zigzag, random and not proper motion. So, that is said to be Brownian movement. But in the case of electrons, we could see the electrons could move from one end to another end with a frequent flow or steady flow, but the flow is restricted in the case of colloidal particles. That is due to the improper force of attraction or improper distribution. The colloidal particles can collide with another particle, so the movement is restricted and the movement goes zigzag. So, this is the kinetic property of colloid. Next we could see the electrical property, optical property, that is Tyndall effect. Tyndall, who is a scientist or chemist from German, he noticed the movement of the and the properties of the colloids by passing light. When he was passing the light through the colloidal system, he could see the path of the beam. So, the light was scattered by the colloidal particles. If the particle is small and if it is scattered all direction, the path of the beam was noticed. So, this property is said to be Tyndall effect. This effect is said to be Tyndall effect. This property is the electrical property, optical property of the light. Next, from this Tyndall effect, it was observed that the three systems such as true solution, colloidal particles and suspended particle can be distinguished by this property. So, another property is electrical property. So, the colloidal particles carrying positive and negative charges, first electric double layer. Helmholtz, the scientist who was noticed the colloidal particles by a powerful ultra microscope, he could see the electric double layer or double layer was established between the positive and negative colloid particles. So, this property is said to be Helmholtz double layer. So, this was observed as that railway track, we could see two tracks are going long way. So, like so, as like railway track layer, he was observed two layers observed, one is positive layer and is negative layer. If the layer continues as long as there should be a appreciable force of attraction between the dispersed phase and dispersion medium. Next one is electrophoresis. Electrophoresis effect is noticed by using this apparatus. Here two limbs are there. So, here one part is inserted with cathode, another part is inserted with anode. So, these two parts are connected to a battery and in the applied electric field, what was happened? The particles, the colloidal particles move towards the with respect to electrodes, positive electrodes and negative electrodes. Then the positive ions move towards the cathode and negative ions move towards the anode. So, here two classifications he also observed. If the ions move towards the cathode is said to be cataphoresis. If the ions moving towards the anode is said to be anaphoresis. So, how it is happened? Just movement of the only colloids particles towards with respect to the electrodes. But the medium is not moved, only dispersed phase. Dispersed phase means, as I said earlier, that is colloidal particles. Hence, it is proved that colloidal particles will have positive and negative charges. Electro-osmosis. So, but in the previous case, electrophoresis, we could see the movement of dispersed phase. That means movement of colloidal particles towards the electrodes. But in this case, colloidal particles or dispersed phase will not move, only the medium, dispersion medium will move towards the respective electrodes by applying electric field, because three compartments will be there. First compartment, compartment A and compartment B, compartment C. Compartment A and C, we have taken only colloidal particles, but compartment C, colloidal particles as well as solution we have taken. But the medium only move towards the electrode, the colloidal particles will not move, because it was prevented by using semi-permeable membrane. So, we can say here medium only moves, colloidal particles not moving anywhere. This property is said to be electro-osmosis. Stability of the colloids. It is very difficult to find the colloids as stable, because colloids will disperse between due to weak van der Waals force. So, it is necessary by adding little bit amount of electrolytes. So, the electrolytes will attract the colloids towards itself, thereby the colloids will be somehow stable. So, we could see these kind of colloids are highly stable, as in the case of lyophilic, but lyophobic colloids only it is very less stable. Lyophobic colloids will not be having any charges. So, when we are adding electrolytes, these lyophobic colloids can be stabilized. Thank you. Once again I said thanks to all. Next class, we will see about the preparation properties and purification of gels, salts and emulsions.